Good morning. Today, we're going to talk about probability again. This whole chapter is about probability. And we're going to use a diagram tool called a Venn diagram in order to help us understand that. And before we do that, we're going to talk about some vocabulary words or phrases. The first one is something that is called mutually exclusive. And basically all that means is that events that can't occur at the same time. So for example, if you're in a championship game, you can't both win and lose at the same time. Those are mutually exclusive. You either win or you lose, one or the other. There's no overlap in that. Complements, on the other hand, are things that complete each other or events for us in probability that add up to 100%, or in probability, sometimes we talk about adding up to 1, like the decimals that we talked about yesterday. So there was the things that we talked about wearing Uggs, and we had one person who had a 25% chance of wearing her Uggs, and then not wearing the Uggs was 75% chance. Those two are complementary to each other because they add up to the total 1 or 100%. Either she does or she doesn't, so the total is 100. So maybe we could write that down as an example. So the example, the total probability of wearing Uggs from yesterday was 25% yes and 75% no, which equaled a total of 100% of the things that could have happened, either yes or no. So in our first example, they talk about people liking football and liking golf. Now there are some people who only like football. There are some people who only like golf, but there might be some people who like both football and golf. So those two events would not be mutually exclusive, meaning there could be some overlap. And this diagram is showing that there could be some overlap. So for example, if we say that this left-hand circle are the people who like football, so in this orange circle here, these are our football people. And in the other circle, the pink circle, these are the people who like golf. We then read what they talk about and see what this means. So first of all, 55% of the people that they surveyed liked football. That means that inside of this circle over here, the orange circle, there should be 55%, or as a decimal, 0.55. And in the other circle, there's going to be 40% of the people liking golf. So in the pink circle, 15% of the people, nope, sorry, my bad. I apologize. 40 is correct. 40% like golf. But they tell us also 15% like both. Now what that means is there's an overlap. People that like both. So inside here, where the golf and the football overlap each other, I'm going to put the decimal 0.15 because that means both football and golf are liked by those people. Now if I look into the football circle, I notice that there's another space in here where it's not overlapped by the pink. These are the people who like football but do not like golf. If 15% like both, how many football people are left over that like football but do not like golf?
40.
How much?
Like 40.
0.40 or 40%. So inside the orange circle, there are 40 more percent that just like the football but don't like the golf. And if you look inside the orange circle now, and you put those two numbers together, you see the 55%. So 40 like football, 15 like football and golf, but all of these people, 55%, like football overall. If I look in the pink circle, 15% like golf, but also like football. That means out of the 40%, there's some that just like the golf. How many are those? 25. So if you're looking at the Venn diagram, what you'll notice is that the numbers all match up. So 55% are inside the orange circle, 40% are inside the pink circle, but 15% overlap because they like both. If we were to add up these numbers, 25 and 15 is 40, 40 and 40 is 80, that leaves some left over. What about the other 20%? They don't like any of those, either one of them. So I put those in a separate part, and what I'll do is down here, inside the square, or rectangle, pardon me, but not in either of the circles, I'll write down 0.20. Those people are the people that like neither football nor golf. Now I can answer my questions. The first question is, are these mutually exclusive? Meaning, do the circles overlap or not? They overlap?
Yeah.
Okay, so then they're not mutually exclusive. If they were mutually exclusive, this phrase mutually exclusive means no overlap. Oh my goodness, come on. So since they overlap, they're not mutually exclusive. If they were completely separate, they would be mutually exclusive. Part B, we've already done. That's what this is right here. We filled in the Venn diagram. This picture is called a Venn diagram. That picture on the right-hand side. And the probability that the students like neither, we just got done talking about, the probability that they like neither was 0.20. You could also write it as 20% if you want to. Either one is fine. Okay, in number 2, we're back to the dice thing again. I told you this, dice problems, card problems, and like marbles out of a bag are super popular, especially in like ACTs, PSATs, that kind of thing. So number 2, we have 2 dice that are being rolled. And event A is the possibility that you're getting a 7. So I'm going to draw a circle. And that's that you get a 7. And then the second thing that they're going to talk about is situation B, where both dice show a number greater than 2. Is it possible to have a number bigger than 2 and also be a 7?
Yeah.
For sure it is. So this is a number bigger than 2. Now there are 36 numbers that we can get. Remember that table we made with the 2 dice being rolled? There are 36 numbers. How many ways can you get a 7 out of the 36?
6.
6, very good. 6 ways. So in the blue circle, there are 6 possibilities. And out of the 36 possibilities, how many ways is it possible for you to show a number, not a sum, but a number bigger than 2? What that means is each die would have to show a 3 or bigger. You might need to look at your chart. So from our chart with the dice, numbers that are bigger than 2 are 3, 4, 5, and 6. And it could be on either die. There are 16 different ways that could happen. But how many ways are there where both it's a 7 and bigger than 2? 7 and bigger than 2. For example, it can't be 6 and 1 because one of the die would be a 1. So that's not okay. So it has to have a 3, 4, 5, or 6 only. How many numbers are both a 7 and both of the numbers are bigger than 2? So 2 is correct where they both die are bigger than the number 2 and the total is 7. So you have to look in your chart for that. So there's 2. Which means that left over in the orange circle there has to be 14 things. And left over in the blue, which is the number 7 for the total, there has to be a total of 4 things. But how many things are possible altogether?
36.
36. So I have a rectangle around this stuff that talks about everything that could happen. And if there are 4 plus 2, which is 6, plus 14 more, that's 20. That means there are 16 other possibilities in here that aren't going to be counted for anything we're talking about. And remember, the total number of possibilities is 36 things that can come up from our chart. So now what we want to know is, what's the probability of A occurring? So if you don't remember, A was the sum is 7 from the blue, and B was both dice are showing a number bigger than 2. And all we really care about in this first question is, what is the likelihood that we're showing something coming just out of the blue circle?
4 out of 30?
Nope, sorry.
1, 6.
Nope, sorry. Just out of the blue circle. Be brave. Be wrong. It's okay. So since there are 6 things inside of the blue circle, and there are 36 things possible, the non-simplified answer would be 6 out of 36, which of course your calculator can simplify to 1/6. The second question says, what's the likelihood or probability that it comes just out of the orange circle?
16
Excellent, 16 out of 36.
Wait, do you not want us to simplify those?
It says, what's the likelihood that both of these things are going to happen? So not only will you come out of the blue, but you also come out of the orange, which means you're talking about the overlap. So the overlap is 2 out of 36, which of course you would simplify to 1/18. I don't have space on my board to do that, but you will do that. And then the letter D says, hey, what about if I don't really care which circle it comes out of? It could be either circle. 20. So this one is equal to 20 things out of the 36 things. If I can pick from either the blue or the orange circle. And the last one says, what's the probability that it's not going to be in A, which is the blue circle, and not going to be in B, which is the orange circle? 16 out of the 36. Again, you would simplify that. So you know that 4 goes into both of them, so that would be 4/9 if you were to simplify that. And again, I'm not simplifying because I don't have a lot of room on my board. Okay, number 3, they give us the Venn diagram